Hi, this is Mrs. LaBarbara. This is Physics Chapter 5, Uniform Circular Motion and Universal Gravitation Video 5. Today's topic is gravitational field strength, G. The objectives are to understand gravity is a field force. That means it's a non-contact force, and G is the field strength. The difference between G, little g, and big G, and the relationship between gravitational field strength and the distance. Be able to determine the value of G at any given instant and apply relationship to solve problems. Also be able to select sketch gravitational field lines in area near objects with mass or between systems of masses. The value of G, not big G, those two are different values. So we have learned in the last lesson that gravity is universal between any two objects. So any object on Earth or near Earth will have this gravitation. Fg equals big G times mass of the Earth times mass of the object divided by the distance between the mass 2 and the Earth squared. That's the distance, not radius. We also know Fg equals m2 times g. This is the weight equation. We set 2 equals to each other. What we have is m2 times little g, gravitational acceleration equals to g m Earth times m2 over r squared. As you can see, m2 and m2 cancels, so we have a new equation for g. So gravitational acceleration is big G, that's gravitational universal constant, times the mass of the Earth divided by r squared. R is the distance at a point, the distance from the Earth. So you'll have a G value that varies inverse squared to the distance from the Earth. So the further you go, the smaller your G is. So the acceleration of gravity is dependent upon the mass of the Earth, approximately 5.98 times 10 to the 24 kilograms, and the distance from the center of the Earth. It has inverse squared relationship with r. As you can see, this G has nothing to do with mass 2. That means gravitational acceleration has nothing to do with my mass or your mass or the mass of your computer. It only has to do with the mass of the Earth and how far you are away from Earth. So again, big G and little g has different values because they are different physical quantities. G is inversely proportional to the distance squared. It's another inverse square law, just like Fg. It has the same relationship to r as Fg to r. So the graph would look like this. That's an inverse squared relationship. G, gravitational acceleration is different at a different location because it's location dependent, it's inverse squared. So we can use this equation to calculate the gravitational acceleration at various points. So I highly suggest you to do this on your own because you'll have to do this on the test. Make sure you are able to find these values. And if you have trouble, come to school and I can help you. Okay, those are the values. As you can see, 50,000 kilometers above the surface. So in this case, the R has to add to this surface. So that is, okay, so this value is already added. So it's a 50,000 kilometers plus 6.38 times 10 to the 6 equals to 5.64 times 10 to the 7. So this distance is the two added together, okay? Gravity is a non-contact force or field force. So how do we know gravity? Why does the Earth exert a force on any objects that's not in contact with it? That is because the Earth exerts a field around it, and this field has an effect on anything that has mass. So gravitational field concept. Gravitational field is a region in space where an object experiences gravitational force. So every mass is surrounded by a gravitational field. So there is a gravitational field around you. There is a gravitational field around me. There is a gravitational field around your computer. So there is the interaction between the fields, result gravity. The strength of gravitational field is inversely related to the distance from the Earth. So the gravitational field from you or me are very, very small. It cannot be detected by any instrument we have. But gravitational field of Earth is very big because of its big mass. So that can be detected. So on Earth, the field strength is 9.81 newtons per kilogram. But as you move away, the field getting smaller and smaller. As you can see, we have learned vector diagram. The length of the vector indicates its magnitude. So this is near the Earth. As you go away, the arrow of the length is smaller, but the direction is still pointing toward the center of the Earth. Let's take a look at this example. In which diagram do the field lines best represent gravitational field around Earth? We know gravitational field around Earth is pointing toward the center of the Earth. So it's not this, not A or B. C is pointing away. That's not right. So the answer is D. Gravitational field strength, G. So we know G has been knowing G as gravitational acceleration. So again, a lot of people think G is gravity. G is not gravity. G is gravitational acceleration. G is the same for all objects. On the other hand, gravity is different for different objects with different mass. So at any point in gravitational field strength G is equal to the force per unit mass, Fg over m. That's called gravitational field strength, Fg over m. And this, from Newton's second law, acceleration is net force over mass. So that's why gravitational field strength and acceleration has the same number. And the unit are same too. Gravitational field strength, we use Newton per kilogram, is meters per second squared. So G has two names, gravitational field strength and gravitational acceleration. The gravitational field strength is a vector quantity which is direct toward the center of the Earth. So is acceleration is also a vector quantity. It has the same direction as gravity, which is to the center of the Earth. Let's take a look at this example. A 2 kilogram mass is located 3 meters above the surface of the Earth. What is the magnitude of gravitational field strength at this location? 3 meters above surface of Earth. Basically, it is the surface of the Earth. Because the surface of the Earth is 6.37 times 10 to the 6 meters. So 3 meters is very, very minuscule compared to the radius of the Earth. So anything I say about 100 meters or more, it is around the Earth's surface. That's on the Earth's surface. We can consider gravitational field strength is G around Earth's surface, which is 9.8 newtons per kilogram. So that is the answer. You can also use the equation to figure it out. You will have the same value. That's it for today. Thanks for watching. See you next time.